Hello, so it's just about 2 o'clock, so we'll go ahead and get started. My name is Rosalind Radcliffe. I'm an IBM Distinguished Engineer, and I'm responsible for DevOps for Enterprise Systems. For those of you that don't know me, I'm the mainframe person that likes to talk about how mainframe can be ZOS as well, can be part of DevOps as well. But this session won't necessarily be all about that. This session will be more about the infrastructure overall, not just Z, but the entire infrastructure and how you can work together. One of the things that's important to understand about this session is it's based on my working with clients, numbers of large-scale clients, in the problems that they have in transforming to DevOps. What do they do because they have this infrastructure team that's responsible for the systems? What do they do when their systems might be outsourced? What do they do with that other set of things? How do they build DevOps teams, or product teams, I should say? How do they build product teams to make this all work and how to make this fit together? The other thing that forms this presentation is the experience of these product teams being built with application ops, part of them maybe, but leaving out a lot of the key critical factors of the operations pieces. And Dev does this first, and then they go play with ops. So that experience has led to what I'm going to be sharing here today. I'm happy to take questions as you go through here, assuming I can see you. The lights are kind of bright, so I will try to see you, and I will repeat your question so everybody can hear it. I want to start with this. We've had lots of sessions this week about product teams and going from project to product, and that's very important. In my picture, you see something else added. There's this other group. No matter what we want to say, unless all of your servers are provided by a cloud provider, somebody maintains the infrastructure. Somewhere you have a help desk. Somewhere you have a NOC that watches the systems. Somebody's going to be doing that. Even if you are responsible for the application as it runs, somebody's watching the systems. And so when we look at this environment, we say we really need a set of product teams. We need to get project to product, but we need a product team that deals with infrastructure. And if we think about them as a product team as well, then it's another product team. It needs to be managed the same way the other product teams are. It needs to have a managed backlog. It needs to have its own pipeline. It needs to do those kinds of things. The other thing you'll see on this chart is this shared resources. Because I haven't met a company yet that has enough DBAs to assign to every single product team. That's just one example. Kick, system programmers, storage, take your choice. You're not going to have enough DBAs to assign to every team. Now, should developers and application ops do more DBA work? Absolutely. Should it be set up so they can do their own work? Absolutely. But is there a skill and an experienced DBA to help you do better design? Yes. So let's use those as shared resources. Let's keep this. And one model that I have seen work, so this isn't the only model, but this is a model, is you have those shared resources more aligned with the infrastructure team. But they are shared resources. They need to work across the board. But this way they can also help make sure the infrastructure is optimized. The other thing that's on this line is this dotted yellow line kind of slightly past the test phase. When we look at this picture, I added that line to say that's really where ops starts. Now you might look at me and wonder why I'm saying that, but When we put together product teams, and I've worked with numbers of companies, they started by putting together their product teams, and they started with development, because that's where you start, right? Maybe. That's where you start. The development team puts the pipeline together, works with some people, maybe. But then they got to get to production somehow. So they need to involve the existing ops organization. Well, really, that whole back half actually needs to be thought of as ops, application ops work, but it is deploying systems. It is deploying the application. It's managing systems. It's monitoring systems. It's making sure all the monitoring tools you're using in other places, like production, are all the way back in the test environment. And so it's that entire picture of having these groups really work together to make this happen. And without this, I've seen many times this transformation hit a brick wall. DevOps is really all about breaking down these silos and bringing the teams together. But if ops isn't playing, then you're never getting to production, or you're fighting that production wall. The other reason that I see this is there are quite a few companies who have outsourced part of their systems. And if you have an outsourcer who's doing this infrastructure for you today, you need a line, you need a boundary, you need an understanding of how that relationship is going to work with that organization. How am I going to work together? How am I going to feed this? And if I think of application ops as part of the team and the infrastructure in this way, I can come up with the appropriate boundaries and the appropriate ways of working. It's something we've defined based on all of the miscellaneous customers that I talk to, which are quite a few. It's a model. Now, I'm always interested in hearing about new models from others. So after this session, if you want to Slack me, I'm happy to hear other examples of what you've done in patterns that make this work. This is one that we have found that's worked in very large companies. Let's keep that in mind. I am mostly talking about very large companies that have lots of systems. When we think about this, what is the infrastructure team need to do? What does the ops side of this DevOps world have to deal with? You're dealing with this demand from applications, application teams, developers to say, I need this. Why are you getting in my way? It's really usually the question, right? Isn't somebody getting in your way? That's what ops does, gets in your way. No. This is what I want. I want on-demand instant systems that meet what I need. Pre-configured, pre-set up. If it's a Docker environment, I want the Kubernetes environment there running that I can just put my Docker container into. If it's a system or a server, I want it there and available for me to use, preferably with all the middleware and security and everything already handled for me, please. Make it as easy as possible for me to do the parts of the work that I'm supposed to be responsible for, by definition, configurable but controlled, so that I can get the work done. When we think about this, this includes network. That's the thing everybody forgets. The network is part of the infrastructure you're managing. They're part of the ops team today. I haven't heard of a company yet that's moved the network engineers into the product teams. Okay, that doesn't even make sense. Network's part of it. All of these pieces are part of this story, and all of them need to be considered. Now, you'll notice on my picture, I've actually broken things down into infrastructure, compute, etc., the management of it, because that's just as important, the config of the middleware that sits on top of that, because in most cases there's something there, the application, we all have applications, and data. And I break data out separately because in a lot of ways, if you can manage data in a way that is data as a service, test data as a service, or fabricated data as a service, take your choice. If you think about that as an infrastructure component that you're providing as a service as well, it helps in this picture as we go through. And then there are dependencies. And I know that when we get to a world of microservices, of all microservices, there'll be no dependencies anywhere, right? Okay, good. Everybody laughs. One, we'll never get to that world, but two, all those microservices are dependent on other microservices to actually do something. So there are dependencies all over everywhere. They may be loosely coupled dependencies. They may be tightly coupled dependencies, unfortunately, but they're going to be dependencies, and we have to deal with those dependencies. When we think about this system, we also have to realize that it's going to run somewhere. Everybody talks about Docker containers or containers, and that's one good place to run things. There are a lot of other things that might be places where you're running your system. You might get a SaaS offering that you're doing something with. You are probably running some traditional VMs still. Most people still are. We've got public cloud. We've got private cloud. We've got Docker, as I said. We've got large systems, IBM Z. We've got AS400. I know there's at least one person in the room with AS400, or yeah, there are a few. We've got IBM I. I should call it IBM I, because that's the real name right now. IBM I could be on this picture. It's the hardware that we're providing. It's being provided in the environment, and I need to be able to deal with this. But how do I do this? And as an infrastructure person, what do I do today? Now, part of this is not going to change. I still have to plug in servers. I don't know how to do that through automation, actually. That does actually take physical work. I have to go physically plug in machines, maybe, when I roll in a new machine. I may have to put it in the environment. But after I've got the machine there, what do I have to do that requires user manual work? Hopefully, it's close to nothing. Hopefully, it's all automated. And probably, it's not. What we need to get to from an infrastructure standpoint is to think about the pipeline in the exact same way we think about the pipeline for an application. I'm defining the configuration of my infrastructure. I'm defining this as code. Maybe I have Helm templates. Maybe I'm doing Terraform. Maybe take your choice. There are multiple methods. But I need to define this in a way that it's code, that it's checked in, and it's deployed, so that it is repeatable, reliable, and much simpler, because I have a repeatable process that now, down at the bottom, service catalog, I have defined the infrastructure. I have defined this infrastructure. It is available. Now my application team, my product teams, have a service catalog. They just request what they need, and they now have it. Now that request might, hopefully, be part of a pipeline, and it's entirely automated, or it may be a request to say, I need a new system to do work on from a development standpoint. But it's bringing these pieces together as infrastructure, but as code to make sure that you can do these pieces. And since I am me, you can even do it on ZOS. One of the things that people look at is I've got Helm charts. I've got lots of different choices in the distributed space for how I can define systems. I create a VM image, I create a golden image, I deploy it, I do lots of things. In the Z world, there is I get a system programmer, and they spend the next 6 months building a new ZOS image, and/or I can't build a new one because that takes too much work. So actually, this comes from a customer. This is a customer example. They took Jenkins and Groovy and Git, and built the automation necessary to create a ZOS IPLable or bootable image, a system image, just like any other system in your organization. Just like any Linux or any other environment, I can create an image, I can IPL it. It can have all the system configuration necessary to run. So no matter what kind of environment I'm working with, whether or not that be cloud, Docker, Z, I can build this image in such a way that it is infrastructure as code, and it can be deployed into an environment so that it is now available for the product teams to use. All of this being infrastructure as code allows you to make it self-service. It allows the teams to have access to these systems and use them. This, if we move to infrastructure as code for this infrastructure team, their product team gets to continue to improve the automation, enhance the automation, and through this automation, do all the other activities that they need to do, like patching and maintaining that infrastructure if you have to, when you have to. There are systems that you still have out there that you have to deal with, security, vulnerabilities, et cetera. I need ways of deploying it. Or in the example this morning in the Kubernetes world, having the Kubernetes world allow it to be able to update itself, in a sense, on a regular basis to remove any vulnerabilities. All of that's configured through this automation. The infrastructure, the underlying infrastructure, is the first piece. I left it out of the chart, but I probably should have said, by the way, the network pieces, most of that is done the same way. And in this particular example, they actually set out the configuration so that they could push out network changes in the same way. They could push out certificates, security certificates in the same way. You can configure different hardware devices in the same way. Most hardware devices have APIs, or I always have to say most because I'm afraid if I say all, somebody's going to tell me there's something that doesn't. But most hardware devices have APIs to allow you to configure them remotely so you can update. But once I have the infrastructure, I now have the second problem. I need to have this pipeline that allows me to use that infrastructure, deploy into that infrastructure in a way that operations infrastructure management is going to be happy with. And you should look at me and say, but it's a Docker container. They don't care. And I'm going to say, you're probably right, maybe. But you don't have only Docker containers today. This world still has a whole bunch of other things, servers, environments, Z systems. There's all sorts of other things out there that aren't to a Docker container yet. And in that Docker container, you're still going to have to manage that underlying infrastructure image of the OS, and you're still going to have to deal with security when you're building the Docker container. So we need to worry about the next phases as well. One of those pieces is defining the process such that the application is deployed into this infrastructure. If you have a standard template defined, this is the way I always deploy this kind of application into the infrastructure, then I can do that. I can have this template, and now the application teams are using, the product teams are using this to deploy their application, but it's in a way that you know it meets security guidelines. It's in a way you know it's not going to cause additional vulnerabilities. You know it's a secure pattern. You know it's repeatable and reliable. In this example, we show a process with Urban Code Deploy, and I have the process set up there so that I can deploy the application into the infrastructure or call infrastructure to be provisioned and then deploy it into the environment. So for each stage of the environment, I can have this same process. But this process is still part of ops. unless I have some control over this process, am I going to pass all the right audits to get me into the system by having the teams work together, the product team work together with infrastructure? I can have an application-defined process that will satisfy all the requirements. Then we get to data. And this is the one that people forget when they talk about this environment. And I have to admit, this is one of the bigger problems, especially when it comes to test. So when we think about the environment and we think about test environments, and we've heard all about security, we've heard some sessions about GDPR, we've heard different discussions about security and what do I need to do. I need to have test data provisionable in my environment that is not going to be a security risk. I want to make sure that I have data that I can use that will allow me to do the right tests at the right time with the right data. And so data fabrication is one of these key things. Now, no chance is any company not, there are too many negatives in that. You're still going to take production data and you're going to mask it in some cases. There's going to be environments such as scalability and performance test in which you're going to want massive amounts of data. That's a good place for production data. Unit test, function test, early integration test, there's no reason for production data. Providing data as a service, fabricated test data as a service, is a way for the infrastructure team to provide the infrastructure around this process so that the product teams can get the data that they need at the right time. And in this example, I'm using the Optum set of products, the Optum test data management, along with Optum test data fabrication. Having test data fabrication and really being able to fabricate data necessary for your scenarios helps improve your testing, helps improve your delivery. Everybody knows, right, that you shouldn't test with massive amounts of production data, right? Nobody tests with large quantities of production data in their environment, or masked or fabricated production data, right? Nobody has lots of copies of production data in their test environment. Yeah, I'm getting smiles. Okay. When you run test from production, you're using good data by definition. Think about that. It's already gotten through your system. It's already put into the data store, the database, the whatever it is. It's gotten processed already. It's good data. So how do you test your application with good data? You don't. Having fabricated data allows you to have this variability. But if you look at this picture, and if you look in most large-scale companies, this fabricated data is a challenge. Understanding the data I need for this test is a challenge. Having the infrastructure set up to do this is a challenge. So by having the infrastructure teams provide the data as a service function, now product teams can go get what they need efficiently because the system's been set up to provide them that capability. The other part of this is virtual services. Product teams, if the world were wonderful, product teams would work totally independently. Two product teams would not depend on each other at all. Now we're in the real world where that isn't true. So we need a service or a set of services that allow the organization to have virtual services. So you can have the infrastructure and the environment set up so that you can virtualize whatever you want to. When you're doing early test, obviously you're doing more mocking and stubbing, but across the product teams, having virtual services to eliminate the dependencies between the teams, to allow them to do the work that they need to do. This is a set of services that need to be provided, but they're not necessarily within the product team, they're cross-product teams. So you need a way of managing this set of resources that's being shared across the teams. Usually, product teams build their virtual service for another product team to use, but it still needs to be managed in a system so that you have it so that everybody has access to it. In this particular case, it's using Rational Integration Tester because that makes it really easy to work multi-platform, particularly on Z, where I might have some interdependencies even within a Kix environment. It's kind of nice to be able to create virtual services there. And so I can easily virtualize these services, and having this provided as a system as part of the infrastructure team allows everyone in every part of the organization to use this capability. It's provided as a service. Now, in the picture you see here, this is an example tool chain demonstrating the different piece parts of the environment. But this picture probably looks a little different than many pictures you've seen. It's got Git up in the corner, like you see many times. But then there's this whole chart that talks about the other side of the world. When we think about DevOps, we're usually talking about what does it take to build my application? What does it take to build it in the first place and maybe test it in the first place? This has all the rest of the environment in the picture that we many times don't focus on, which is why in this discussion we're focusing on this back half of all of the infrastructure and ops related challenges that are part of this story. But you also see there's no reason that the infrastructure team can't be using this exact same pipeline. I've got my infrastructure as code stored in my Git environment. I have my virtual service definition stored in my Git environment. I have the code customized for the rules for data fabrication stored in my Git environment. So it's all managed in a consistent way. If I want to make a change in the environment, I deploy it through the system. I was working with a company recently that talked about how they were doing a system upgrade underneath the applications. Applications run on systems still today. They're running an operating system. In this case, it was Linux. They needed to install a patch into the system. They didn't have a pipeline for infrastructure. They needed to get it done, worked with the application teams, but because of schedules, they couldn't get it on the test environment or the dev environment. They tested it on their own simple machine, but not with the application. They did the roll to production. At the same time, they did a production update. What do you think? How well do you think that went? I see a lot of faces. If the infrastructure changes roll at the exact same time as the application changes roll or coordinated so that they're not totally separate, then you have the changes together, you know they work together, and you're not going to cause a problem like this organization had. The other thing that I heard this week was a discussion about I can't do my changes on X weekend because that's the weekend they IPL the system. Or I can't do my changes because that's the weekend we patch the system. Okay, you're taking the system down to patch it? Why aren't you putting the application updates in there at the same time? You already just took it down. You might actually want to make sure it comes up with the patches first and then install. But there's no reason to say these changes can't happen in a coordinated fashion at the same weekend. You don't have to remove weekends from your releases just because you've got to do patches on the system. You need to coordinate these together. And if it's a pipeline, then it's exactly the same anyway. I'm rolling through the pipeline. I can make these changes. The other advantage is, what if you need to make a change right now because of something in the infrastructure? One example is security certificates. Somebody in an organization forgot to check when their certificates were going to expire. And something happened, and they all expired. And so they had to update them. How do you update your security certificates in the environment? You go around and change them all? There's some process. I actually hope it's automated to some extent. If it's in the pipeline, it would have been an easy push. I could just make those changes. So hopefully, this has been helpful and useful. The idea of this is to get you started thinking about, what do I need to do if I'm a large-scale organization that's not going to be able to get rid of my ops? Not that anybody's actually ever getting rid of ops. People just talk about it. We still have product teams. The product teams have to have ops as part of them. They have to be part of this team. But you also need to make sure that all of your infrastructure changes are flowing in the same way, the same kind of product team. It's just a different set. They work on infrastructure instead of working on applications. Thank you very much. Appreciate your time. Enjoy the rest.